Hey, Vlad here, Tilde Command, and welcome to the second episode of the Scala playlist. Now, this video is called Introduction to Scala Build Tool, but in fact, it's an introduction to build automation in general. When we write code, it's usually stored in text files. In our case, it's text files with the extension of .scala. We're going to go through the whole pipeline of transformations to that code to see what exactly happens to it and which tools we need to convert all of that into something that a microprocessor can understand. I could have just shown you how to install the tool and how to make it compile Scala files and how to run applications in it. But as I already mentioned, this is not a crash course, this is not a tutorial. We have all the time in the world. Also, I realized that my previous video was scheduled to come out on Christmas, and this video comes out right on the New Year's. So happy belated Christmas and a Merry New Year. Okay, so the first thing that we're going to talk about is this whole pipeline of transformations to our .scala files. But we're not going to discuss it top to bottom. We're going to go the other way around and have also a sort of a history lesson. We're going to start from the bottom and build everything to the top. In the beginning, computers used to be mechanical, but these days they are electronical. So the first question is, how do we get our ones and zeros, which are digital, how do we convert them into analog signals, into analog waves? And we're not going to discuss that in this video exactly, but the basic idea is that if you have a wave, if you have a signal, then there is a threshold. And if the signal is strong enough to be above that threshold in terms of voltage, then we record a 1. So 1 means that electricity is flowing, and 0 obviously that it's not. This already makes the first layer of our abstraction. So now we're not talking about analog signals anymore because computers are electronical. We're talking about ones and zeros. So we made this leap from analog to digital. And in fact, the first computer programs, they were written like that. They were literally written with ones and zeros. We used to have punch cards, and the punch card, you can imagine it as a regular cardboard card with a table in it. The table had rows and columns, and in every cell of this table there was a hole, and if the hole is punched, then it's a 1, and if it's not punched, then it's a 0, and then you would feed those cards into a computer and it would evaluate them. A bit later we used a different technology to write our code, but it still stayed digital. It still stayed ones and zeros, which is also sometimes called machine code or machine language. The purpose of this video is not to explain to you exactly how a computer processor works or how it interprets the machine code. The purpose of this video is to get you starting working with Scala and also give you a bit of background information. So I can't explain everything in detail. But basically, if you look at code like this, this 10010110, you could think of that the first part of the code, 1001, would describe what to do with the rest of the code, 0110. So basically, the first part would be an operation code. You would tell the processor what to do, and the second part would be an argument. And in fact, what happened later is that we created mnemonics. Or actually they were called operation codes for them, and this is the next layer of abstraction. So we created those mnemonics like load 60 into the register called A1, and then we created tools that were called assemblies that would take this assembly code and assemble it together, or basically convert it into machine code, into ones and zeros. Now, the goal for this was obviously to reduce human error, but there was a problem even with that, because this was a one-to-one transformation, which means that if the computer hardware is changing, so if your computer is changing, then you still need to rewrite the whole program. The same thing would happen with machine code, but over there it's kind of obvious because every processor has its own list of basically operation codes or instructions. So the next thing that was done, we created applications called, well, I'm saying applications, I'm going to say programs. So we created a program called a compiler, and the name doesn't mean anything. I actually have no idea why we picked up that name, but what a compiler was doing, it was taking a language that was even higher. So it was a completely abstract language, and convert it into assembly code. So we had abstract source code like a equals 60, and it would convert it to opcodes, right? So it would convert it to something like load 60 into the register A1, and that thing would be converted into 1001, 0110. By the way, all this text and all these numbers, they're just made up, right? They're just for illustration purposes. So there were a lot of cool things about this approach. The first thing is that you write a program only once, right? And then you can have different compilers for different processors. So whenever a new processor comes out, all you need to do is to have another compiler, and all the hundreds of programs that you have written, you would not need to rewrite them. The second cool thing about this is that programmers had a bit more power. They didn't have, they lost a bit of control over exactly what is happening on the processor, but they had a bit more expressive power, right? So they would write one instruction in this abstract source code, but then it would get translated into 10 instructions in assembly, and for assembly, that was not the case. So the 10 assembly instructions, they would still get converted into 10 machine code instructions, right? The third benefit of that was a reduced barrier of entry. So before compilers, people who were writing, ones and zeros or assembly code, they were basically, computer scientists. I mean, technically, in the very, very beginning, computer science as a field didn't even exist, but eventually it did exist. And then computer scientists were writing that code. But once we introduced compilers, people from other fields were actually able to write code. People from math fields or other engineering fields and so on. So it reduced the barrier of entry, and more code has been written. Okay, so these three levels, and by the way, they're called 0, 1, and 2 because the first, the level 0, I don't even really count as it's not really sort of part of programming. It's more like electrical engineering. So yeah. So I'm going to say that these two are, whatever. Let's say these three levels are the main levels. Everything that happens above is just, first of all, it's not so straightforward to understand anymore because it's sort of like the same thing, but it's kind of different. And secondly, it's always the same approach. So from now on, we basically have compilers that convert some higher language into lower language, higher language into lower language. This is basically what compilers do in general. But the initial compiler is on this level number 2, the compiler that converts into assembly code. So the next thing that we did was we created operating systems. So now you did not need to create a compiler for each individual processor or each individual processor architecture. It was enough to create a compiler for an operating system, and the language that you would use, it would also have access to so-called system calls, and system calls are a way to call specific functions, specific instructions, basically in the operating system kernel. But the idea is still the same. We have compilers that would compile some abstract source code into something that an operating system can understand, and then an operating system would have a sort of like a built-in compiler, you can imagine it like that would convert it into opcodes, right? And then you would have an assembler that would convert opcodes into machine code, and so on and so on and so on. Okay, so the next thing that happened were virtual machines. Virtual machines like the Java virtual machine, for example, or the .NET runtime. And you can think about them as it's like an operating system that does not run on hardware. It runs on top of another operating system. So technically it's not true, but for illustration purposes, it's actually accurate enough. So when you go to java.com or whatever the website is, and you download Java, what you're actually installing is this Java virtual machine, this Java runtime. So this Java runtime will take your, again, some higher abstract, source code, and it would convert it into something that can run on your operating system. The benefit of that is that you write one application and you don't even need to recompile it for different operating systems, right? Because the vendor of the virtual machine, in this case it's Oracle, it used to be Sun Microsystems, now it's Oracle, that maintain this virtual machine. So what they do is that they have a version of this virtual machine that runs on Windows, and they have a version of this virtual machine that runs on Mac, and they have a version that runs on Linux systems, right? So you write this application once and they make sure that it runs on all underlying operating systems. And again, the operating system makes sure that it runs, on that it assembles the code and so on. It all goes down to ones and zeros in the end. Okay. So what happens now is a very crucial point. So now we have those virtual machines, but they usually come with a programming language. And in our case, we're in the Java world because Scala runs on the Java virtual machine. What happened was that a language was also created, and unfortunately it was also called Java. So when you hear people say Java, they might mean the Java virtual machine, or they might mean Java, the programming language. So I'm gonna undersell Java a little bit, but basically there is nothing cool about Java, the programming language itself. The cool thing about this whole Java system is the virtual machine. The virtual machine is amazing, and historically there was this period of time where the Java, the programming language, was not being developed that actively. And this was the time where we had a bunch of alternative programming languages that would still run on the Java virtual machine, and Scala is one of them, if not the most important one of them, because the inventor of Scala, Martin Odersky, was also the one who at some point rewrote a compiler for the Java programming language, and at some point his compiler was actually used for the Java programming language. So even though there are a lot of alternatives, so a lot of alternative languages that run on the Java virtual machine, Scala and a handful of others are the most important ones. So this is a level 5 where you have other source code that runs on the same virtual machines. And by the way, this is the level where we will work in this playlist, right? So Scala is a language that generates the code that can run on the virtual machine. And by the way, in case of Java virtual machine, this code is called bytecode. We will see later that we will have our Scala code in the .scala files, and once we run our compiler pipeline, it will generate the so-called .class files, and what is inside of them is the so-called bytecode. And the same thing happens for Java. So in the Java world, we will have .java files. In fact, I will show you a few examples later, and the same thing is happening to them. So once we run them through the compiler, .class files are generated. So basically the same bytecode. There are only 2 levels left, and I have to say that they're not really super important to understand because we're not talking about them in this playlist. It's more like a look into the future, and also to see where this whole thing is going. So the next level might be, and in fact this is what is being tried out right now, is that you would write a very abstract source code like, let's say, Scala code, right? But then it would not only run on the Java virtual machine, but it would also run on the .NET runtime, or it would also run in the browser, for example, right? And so on. But again, we're not talking about this in this playlist, which is why I'm not going to talk about this too much. The last level of abstraction that we have here is source code to other source code. What you can do right now with Scala is that you can run a certain compiler, and it will convert the Scala code into JavaScript code. The thing is that JavaScript, most implementations of JavaScript are interpreters, right? So technically you could think of it as there is no compiler. It's just something that reads through the source code and runs it right away. So we have a special name for compilers like that. It's compilers that convert source to source, and they're called Transpilers. Another reason why they're called Transpilers is that a compiler usually converts a higher level language into a lower level language, and in this case you can compare Scala and JavaScript as you can see them at the same level of abstraction. So usually, if you have source to source, usually it's a transpiler. So we're basically done with this, and there's a lot that can be said about this. But again, the goal of this is to get you started with Scala as soon as possible. So the next thing that we're going to do is we're going to start with level 4. We're actually going to create a tiny hello world application in Java, and then we'll see the tools that we need to get Java running. And then we're going to do the same thing with Scala, and we'll see which tools we need for that. I'm in Ubuntu right now, and I have a whole playlist which explains how to install Ubuntu in a virtual machine. Everything that I'm doing right now, you can always also do in Windows, but as I already mentioned in the past, I prefer Ubuntu for software development, and you will see why in a few seconds. So the first thing that we're going to do is we're just going to open the terminal, and I'm in my home folder, and what I will do is I will just create a folder called there is a first time for everything. I just made this up. All right, so we're gonna go in there, and inside we're going to create a folder called Java-stuff, and we're also going to create a folder called Scala-stuff, and we're going to go into Java-stuff, and actually, you know what, let's not do it like that. Let's go back and open this whole folder in Sublime. So if I say subl dot, it should open Sublime. I'm going to close this one. I'm going to maximize that one. I'm going to press Control KB. So we have a folder called there's a first time for everything, and inside of it we have a folder called Scala stuff, and we have a folder called Java stuff. So we're just going to create a file in Java stuff, and it's an empty file, so we're just going to call it main.java. This is not a Java tutorial, but the thing about Java that you need to know is that the file has to start with a capital letter, because what is inside of it also has to start with a capital letter. So we have a file called main.java. So what we have to have in here is a public class main. Okay, so the name of the class has to correspond exactly to the name of the file. This is not the same in Scala. And again, don't get hung up on the syntax, because I didn't really explain what that is. I didn't really explain what that is. I didn't really explain what that is, and I also didn't explain what that is, because today we're not learning about programming languages. We're learning about how to make applications run. Right? We're learning about build tools. So the first program that every programmer writes is the one that prints out hello world. So in Java you need a semicolon, and also just printing out stuff in Java is a bit tedious. Okay, so you're a programmer, so you created this application, and once you run it, the first thing that the application is doing, it announces itself to the world. It prints out on the console hello world. So now we have this text file. How do we actually get it to run? And this is what this whole video is about. Well, technically it's about how to do it in Scala, but we're gonna get there in a few seconds. Okay, so the first step, the first thing that we need to do is we need to convert this into machine code. And again, because we're in Java, we don't actually have to convert it into machine code ourselves. It is enough to convert it into bytecode that the Java virtual machine will run. So as of right now, we don't even have the Java virtual machine, but as of right now, we also don't really need it, because the first step is just to compile it, right? To convert it into this bytecode. And for that, we need a tool called Java Development Kit. So you can just go to the Java website if you're on Windows and just download it and install it. You know, it's a simple installer. When you're on Ubuntu, there are also many ways to do that. You can do the same thing. You can go to the website, just download it, install it. It's going to be a Debian package probably. What you can also do is you can go to the console, and it doesn't matter in which folder you are. In fact, let me press Control L. You can say sudo apt-get install, say yes to everything, and if you don't understand what I'm doing, maybe you should go back. You might want to go back and watch my Ubuntu series. What you want to install is default-jdk, which stands for Java Development Kit. There are a few of them. There is an Open JDK, which is open source, which is like the base of all the JDKs. But you don't really need to care about that. So if you're just learning Java or Scala, this is what you need. Okay, so it took about 15 seconds or so, and I'm actually not sure if it's going to work like this, because I believe I never installed the Java Development Kit before I actually installed the Java Runtime environment, so the actual Java virtual machine. But we'll see. We'll see. So now that it's installed, we can say Java C -version, Yeah, so the version is 1.8.0_151. So what we can do now is, and by the way, the rest, these tools are built for the terminal, right? Which is why I spent a lot of time to explain to you how to install Ubuntu, how to work with the terminal, because it's actually important. All right, so we need to go into this Java folder, right? So over here we have the Java stuff and Scala stuff. So if you go to Java stuff, we have the folder, the file called main.java, right? So what we install right now is Java C, which is the Java compiler. Remember compiler, the one that will take your source file and compile it into bytecode. So if we say Java C, and we just give it this main.java, assuming that it doesn't contain errors, and in fact in this case it does contain an error, it will convert it into bytecode. Okay, so as of right now, we're seeing errors because Java is not a scripting language. So you can't just have statements in the code that would just run. They have to be inside of a very special entry point. And this entry point in most languages is called main, and it's a function. And again, I can't explain this in details, but basically this thing has to be inside of something, right? That's what I just said. So that thing has to be inside of something, and the something is a public static void main, which takes an array of strings as arguments, and this is the entry point. I believe I did it right. Yeah, I think so. Okay, so Java C, main.java, and now it actually works. So now if I type ll, we actually have this main.class file. So it actually worked without the Java runtime environment. So we didn't actually install Java. So let's go up again and find the command that installed the Java development kit. And all we need to do now is to say, instead of the Java development kit, we need the Java runtime environment. And we're going to install that. And oh, I guess the Java development kit also installed the Java runtime environment. Let's see, Java version. All right, there we go. In any case, so now we can actually run this application. So let's type in ll again. So we have the main.java file, which was the source, and main.class file, which is the bytecode. By the way, if I cat into main.java, and cat is an application that just goes into a file and prints it out. And if it's a text file, then it looks good. But if it's not a text file, then it looks like that. It's kind of weird. You can still sort of see part of the code, but there are also like weird characters and stuff. Okay, in any case, so what we need to do now is we need to say Java main. And when we say main, what it does is it looks for the file called main.class, and inside of it, it actually looks for the class main, and then inside of it, it looks for this function, and it executes the code that is written over here. And the only code that we have there is hello world. Right? So if we do that, we should see hello world. The next tiny thing that we will do is we're going to replace hello world with Java util arrays to string args. So you don't need to understand that, but basically the arguments that we're passing to main are coming in here, and now we're just printing them out. So remember in the Ubuntu videos, I showed you how to pass in arguments to bash, and also made the video about the scopes, those arrows with boxes and elves. Maybe you should watch that again. What we have to do now is, if we run Java main and we give it some arguments, nothing's going to happen because we didn't compile it, right? So it still just says hello world. So we need to actually say Java C main.java, and it just replaced this .class file. So I'm going to type ll now, and you will see that the time is not 1902 now. It is actually 1905, because this is what just happened. We just compiled it again. So if we run Java main now, we will see an empty array because we didn't pass in any arguments. And if we actually start passing arguments for a second, then we actually see those arguments. Now, this video is an introduction to the Scala build tool, and the purpose of this whole, for these build tools is to put gigantic applications together and make them work. So gigantic application means, as of right now, we have one Java file. In an actual software project, you will have thousands of them, right? So you would need a tool that would, go through the folder of yours. It would figure out, okay, which files are, Java files, where to compile them, how to bundle them together, and things like this. So we're gonna get that in probably just a few minutes. But as of right now, what you need to understand is that this build tool, usually what they do is they take everything and they put it into one thing. And this thing is usually an archive of some sort. In Java, it's called Java archive, or short jar, was a metaphor over an actual, jar. So we can create a jar with also only one file. I'm just going to show it to you just for understanding. You don't really need to memorize how to do that, because again, we're going to have a build tool that will do all of that stuff for us. Okay, so we already have our .java file compiled into a .class file. So the next thing, the next part is to create a jar, and the way we do that is by saying jar create file entry point, and you call it somehow. It has to have the extension of jar, because it's a Java archive, right? And then you say how the main entry point is called, how the main class is called. In our case, it's called main, right? And then you actually give it the .class file, right? So the compiler receives the Java file, that thing receives the class file. So if I did everything right, and it looks like I did, what it created is this app.jar file, and it doesn't even need to be executable. Yeah, it doesn't need to be executable. Right. So the way you run it is the same as before, where previously you said Java main. What we need to do now is to say Java-jar and then just give it the jar, right? And if you want to pass in the arguments, you do the same thing. First, second. So now you understand how Java applications are built. And for Scala, it's going to be similar, because somehow we will also need to generate those .class files, because Scala is getting compiled into the same bytecode, okay? But obviously we can't use the Java compiler for that. We need to have a Scala compiler for that. So before we start that, let's actually create a Scala application. So we go back to our Sublime. By the way, app.jar is a binary file, so it looks like that. And I think if we cat into app.jar, yeah, we also see binary stuff. So Scala stuff. So in Scala, the file can be called wherever you like, and I'm not saying you should do that. So I'm doing this just for demonstration purposes. So I'm also going to call it main.scala, but I'm going to use the small main, right? And it's over here, and inside of it we're going to have an object, and I'm going to call it completely differently, again, just to demonstrate that. I'm going to call it let's just say program, and it also has a name. It looks a bit differently, but basically it's the same. That's an array strings, and it returns a unit. Whoops, unit, and inside, so it could have hello world. But I'm just going to go and do exactly the same thing with Java util arrays dot to string, and I'm going to do it, pass in args, and we need a weird thing over here to say that it's actually an array of object. Ignore all of that, right? I'm basically creating the same application. In fact, let me do that. And let me put Scala over there and Java at the top, right? So we have Java and Scala over here. They do basically exactly the same thing, a bit of different syntax, and yeah, that's it. So let's go into Scala stuff, right? So over here we have main.scala, and we don't have anything .java, right? Because we're in the Scala world. So what we need is a Scala compiler. Again, by the end of the video, I will summarize which of these tools you actually need and which of them I just use for demonstration purposes. So the next tool that we're going to install is the actual Scala compiler, and you don't really need that because you will have the Scala build tool that will build everything for you. But I personally, I still prefer to have it, and separately to to have Spt and to have the Scala compiler, and I will explain that in a few seconds unless I forget. All right, so let's go to Firefox or Chrome, it doesn't really matter, and go to scalalang.org, scalalang.org, right? So the latest version is 2.12.4, and you can just go to download, and let's see what they have here actually. Okay, so first thing that they say is, okay, you need Java, in this case the Java Development Kit, and Actually, technically, I don't really know why you would need the Java development kit. It should be enough just to have Java. In any case, we already have that. Then they say you can either download Sbt, which is what we're going to do in the future, in a few minutes, or you can download IntelliJ, which is an IDE. We're not doing IDEs here, by the way. I'm just going to mention that if you have an IDE, usually it comes with a Scala compiler and stuff, but we're not doing that as well. We're not doing that anyway. Okay, so what I'm going to show is actually, where's the... Yeah, so it doesn't even really show download the Scala binaries for Unix. Where's that? Yeah, I also don't like that. All right, so what I'm going to show you is if you go to scalalang.org, if you just go to /files, and then you see this this directory, and then you go to archive, and then over here you should find the 2.12.4.debian package, right? So this is the file that we need. So if you just right click on that and just copy link location, and then you just go into your terminal and just type in wget, which is a tool for downloading stuff, and you just paste that in, then it will download it. It should take just a few seconds, right? So it's in that folder. So now we can just say sudo debian package install scala 2.12.4.debian. Wow, that took almost like 30 seconds. All right, so let's close Firefox, and also let's, we don't need this Debian file anymore. It's like an installation file. We don't need it. Okay, so as of right now, we can say Scala probably version. Does that work? Yeah, 2.12.4, and I'm sure we could also say Scala C version. Yeah, so it gives you the same thing. So whereas we need the Java compiler, whereas we needed the Java compiler to compile the Java code into bytecode, we need the Scala compiler to compile the Scala code into bytecode. Okay. So again, we're in this folder where we have our main.scala. So I'm sure they would do Scala C main.scala unless I have errors. Of course, I have errors. All right. So I just hope that this would work, but it didn't. In any case, let's just do that. Make string, and we want to start with that, and then we want to have a comma space, and then we want to have that. Let's do that. What's the problem? All right, I'm being too tired. I should not record those videos in the evening. There we go. All right, there we go. So what you see over here is that from one .scala file, it actually created multiple .class files. So as you can see, it tried to be really compatible with Java. So it tried, it created a file that starts with a capital letter. It actually called it program because of that, right? And I can't explain you right now why it created two files because I would need like half an hour at least to explain you that. But all you need to do now is that now we have this bytecode, right? So how do we run it? Hopefully the same way. Let's try it. I put a Java program. Let's see what happens. It says no class def found error, blah, 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 class not found exception. So what happened is that first of all, it worked, right? So Java understood that this is bytecode, that this is a program, but it couldn't run it because it couldn't find something special that Scala needs. I won't explain that. All you need to know is that if you want to run Scala files like that, you would just need to use Scala instead of Java. There we go. And the same with hello world. Hello world. I'm not going to go through creation of a jar file because it's I believe it should be the same, but again, it's not going to work because this thing is still not going to be there. In any case, the last thing about this that I'm going to show you is what you actually have installed. So we didn't really install only the Scala compiler. We also installed the thing called the Scala Ripple. And if I start it, if I just type in Scala, what you will see is this interactive loop that you're stuck in. So REPL stands for read, eval, print loop. So it says here type in expressions for evaluation. So as of right now is in this read state. So whatever we type in here, like print line, hello world. Once you press enter, it will evaluate that expression, and then it will print out the result, and then it will do this loop again, right? Print it out. You can use it as basically a very fancy calculator. You can say 1 plus 2, and you will have a 3, and this 3 is stored in a variable called res1. So if you do res1 plus 1, we should see 4, and 4 is stored in res2. So if we do res1 plus res2, and you can also store it in a variable called my favorite number equals, yeah. So basically as a favorite calculator, and now you can print line my favorite number, and also has auto completion. So I just pressed tab and it auto completed to favorite number. So I'm pressing tab, my favorite number. Right. Okay, so this is not an introduction to the Scala Ripple, but yeah, this is how you can play around with Scala. But I don't advise you as a beginner to start learning Scala like this, because this thing has a lot of special things. Should I try? Yeah, let me try to reproduce one of them. So if I just create a list from 1 to 1000, and I'm just going to say to list over here, and I'm going to put it into a variable called, no, I'm not going to put it into a variable. Let's just type an enter. So if I tap enter, what it's doing is it doesn't print out that list until the very end. It's a feature that is built into this read eval print loop into this REPL to cut off things, right? And this is not what you should have as a beginner. Like as a beginner, you know, this is just going to confuse you, right? Because if you actually type in print line, right, and put the same thing in there, right, which is what you would be forced to do in an actual Scala program, you would actually see, you know, exactly what you expect. It goes from 1 to 1000. You can scroll up and you can see it starts with 1, goes until 1000. All right, so we finally arrived at Spt, and my recording software tells me that it's been almost an hour, which means that after I edit this, it will be, I don't know, probably like 15 minutes. So I'm guessing that we have like 10 minutes left. We can do this. Okay, so the first thing that you need to know about Spt is how to install it. And install it on Windows is simple. You just go to simple, Spt stands for Scala Build Tool. So if you go to Firefox, and if you just Google Scala Build Tool, the first thing will be scalabuildtool.com, I think. No, scalabuild.org. Yeah. Yeah, so you click the orange button, it installs it. The way we install it on Ubuntu is a bit different. And in fact, what I'm going to show you is that I created a script file that would install Spt and Java and the JDK. We're not going to use it here. I'm just going to show it to you real quick. It is over here. On my GitHub, github.com/devInsideYou/install Spt, and I've written it in such a way that if you just copy these 3 lines and you paste them in your terminal, you will have Spt installed, you will have JDK installed, and JRE. And we're gonna go very quickly through what exactly it's doing. So the first line uses wget. You remember, it's the same tool that we used to download the Scala compiler. It will download a file called install.spt.sh, which is right here. Right, and then it will make this file executable by doing this +x, and then it will just run it. And the last line of that script is also going to remove the script itself, so it's going to clean itself properly, right? So let's just go into here. And all it's doing is it installs Spt, it installs Java, the same as we did, then it installs JDK, it shows you the versions, and it removes itself. So we already have all of that stuff. That's why we're not going to copy paste those 3 lines. What we're going to do is we're going to paste those 4 lines. So let's copy them and paste them in. Let me, oh, by the way, you exit the Scala REPL with Control-D, right? Okay, so let me press Control-L. So we're pasting those 4 lines and pressing enter. So now it's installing Spt. In the background, let me actually, hold up. In the background, let me explain to you what is actually happening. So the first thing what's happening is that we're adding a repository into a special place in Ubuntu, and we also adding a special key to also a special place in Ubuntu because the package that we're downloading, the SPT itself, it's encrypted, so therefore there's some safety procedures involved. And then we just update the cache of apt-get, and then we just install SPT. Okay, so now that SPT is installed, let's actually create a third folder. So we have Java stuff, we have Scala stuff, and let's just create a folder called SPT stuff. Okay, and in that folder, let's actually go in there. And the first thing that I'm going to do is I'm just going to start SPT inside of that folder, because SPT can be interactive, so you can just start it, and then inside of it you can do stuff like we were doing with the Scala Ripple. And the reason I'm doing it right now, because SPT, the first thing that it's doing is it downloads SPT itself. Now this sounds confusing, but what we just installed was not SPT itself. I think it's called Sbt Launcher. So Sbt Launcher, it knows where SPT is online, and it just downloads it and installs it, which is kind of cool. Also, in the preparations for this video, the SPT version that I was using was 1.3, and as you can see right now, there's actually 1.04 that I didn't know existed. It probably was released today, actually, which is kind of excited because there was a bug in there that I didn't like. In any case, as you can see, it downloads a bunch of things. In the meantime, we're gonna go to Sublime, and remember we have this Scala stuff was a main. We have SPT stuff. Inside of SPT, let's create a file called I don't know. Let's call it proper program is fine. Proper program.scala, and let's just copy paste that Scala program, and let's also call it proper program, even though we don't need to do that. Remember? Okay, proper program.scala. Okay, so SPT downloaded everything, and it also says no, SPT is version set and project build properties. If I am not wrong, if I'm exiting, SPT was Control-D again, and I started again, it should actually generate this build.properties file. If it doesn't, okay, it doesn't. All right, so if you want this warning to go away, all we need to do is, is we need to go into the SPT stuff folder, and we need to create another folder in there called project. It is always called project. It doesn't matter how your project is called. This folder literally has to be called project. And inside of it, we're going to create another file called build.properties. It has to be called like that. Okay. And inside of it, we're going to say spt.version equals 1.0.4, right? Like that. You can also have spaces over here, but I don't know why. Most tutorials have, even the official website doesn't have spaces over there. So basically what's happening is that whenever you start SPT in a folder, it assumes that inside of it is a Scala project. And then it looks for this file. And if there's a version of SPT specified there, it will actually download the SPT version that you specify. But if it doesn't, it just goes and downloads the latest one. And in software development world, you want to have control over everything, over every little tiny version. You don't want it to randomly download the latest one, because as of right now, which is a perfect example, before I started recording this tutorial, I did not know that SPT 1.0.4 was out. So yeah, in fact, right now, maybe I should specify, 1.0.3, but let's just wing it. So in any case, if I exit SPT now and go in back again, it should not display this warning. Yeah, so now it actually downloaded some extra stuff. I don't know why. In any case, now we don't see this warning. And just to demonstrate this real quick, I exited again. Let's actually go and say 0.13.6, which is a version that I know. So if I start SPT, all of a sudden over here, it's going to start saying getting org Scala SPT, blah, blah, blah. I'm just going to kill it with Control-C because this is not what I want. Let's do, what was it? 1.0.4. Okay. And yeah, let's do that again. SPT. All right. So, by the way, this is also one of the reasons why I have Scala installed separately as well. Because once you're inside of SPT, you can always say console, right? And it will start this Scala Ripple inside of the console. But it will take some time, not too much time. Like the first time it actually, right now, it downloads the actual Scala compiler for Sbt. It should take like a few seconds. But the next time we start console, it's going to be a little bit faster, but not as fast as Scala, right? So, okay, so we're in the Scala Ripple, 1+2, and if we press Control D, we're back in Sbt. We're not back in Ubuntu, right? Let's do it again, and now we're actually in Ubuntu. Okay, so just to demonstrate, this is how fast the Scala Ripple starts. Boom, it's there. And if you just wanted to start REPL through Sbt, you would say Sbt console, and it's just longer. Like even if it's an empty project, basically it's just longer. Look how long it takes. There you go. Okay, and if that project actually had some files in there, some configuration, it would take even longer. This is the only reason why I have Scala, because it's fast. So usually, you know, when I forget something about Scala, I just go into the REPL, I play with it a little bit, I close it. This is the only reason why I have it installed. Otherwise, just having Sbt is enough. Also, the Java development kit is technically not necessary. So Sbt can also build Java files, but usually if you're doing Scala, you don't really need that. So if you have just Scala code, then you don't need the JDK. You still need the JRE, but you don't need the JDK. Right, so let's exit the REPL, and let's look into that folder. So in the Sbt stuff folder, we have project, and project has this build our properties file that we created, and we have our program. But what's up with that? What's target? So if you go into target, like this is the folder that was generated by Sbt, and this is where it will put the bytecode and all the stuff, all the other stuff that it needs in there. Let's actually demonstrate that. So let's go back in Sbt. We need to be exactly in that folder, Sbt, all right? Sbt. And remember, inside of it, we have this proper program, right? So if we're inside of Sbt and we just say compile, it should find this program and compile it. I'm not sure if it did, actually, because that was kind of fast. Let me split the window and go into target. All right, so it actually did compile. So it understood that the Scala version, it just took the latest Scala version. Again, because we didn't specify it anywhere, it just took the latest one. It did not take it because we have Scala installed. It just took the latest one, okay? So we can ignore the streams folder. Let's go into Scala 2.12, and there will be classes and some other stuff. And in classes, we have exactly the same thing as when we compiled them manually. And this is what build automation is doing. Like this is the basic task of what it should do, right? It automates this whole compilation process, but it actually does like millions more things, and you really need them. All right. So in this terminal, we have compiled it. So now all we need to do is to say run. No jars, no weird things. And if you want to have arguments, you do the same thing. You say run hello world, and you have your argument. You have hello world over there. Okay, so these are the basics of Sbt. Actually, let me show you one last thing, because this is not like a proper like full introduction to Sbt, but there are a few things that I want to show you. So first of all, you can chain tasks, right? You can, for some reason, it has to start with a semicolon, right? And then you can say compile, and then you can say run, right? So now, if I change something over here, let's say I print out hi, I save the file, and I press up, the same as you would press in the terminal. I just say compile run, it compiles, and then it runs. Now, let me close the other one. Now, Sbt is actually smart enough to understand that it needs to recompile stuff when you run things. So if I run again, it already knows that it's compiled, right? But if I have world over here and I do run again, it will actually understand that something changed, and it will compile, and then it will run. See, that's exactly why you need build tools, because they do all of these cool things for you. But if you don't understand what exactly they're doing, you're gonna get lost pretty fast. Imagine if I started my video with that. This is how you install Sbt. Just one script, right? And you just throw in a Scala file and you just say compile run, and you're good, right? Any case, the last cool thing that I want to show you is the tilde command. So if you have a tilde, and then you have something, have another command like run or compile, what it will do is it will sit there and wait. So it will run the application, and now it will sit there and wait. It will say waiting for source changes. Press enter to interrupt. So if I press enter, it's going to be interrupted. What is that? Come on. Are you serious? New versions. Man, oh man. Did they break this thing? Come on. Run. Enter. Oh my god, they broke it. Jesus Christ. All right, so what we're going to do is, the first thing that we're going to do is we're going to say Spt Clean, and Spt Clean will go to this target folder and remove everything. Okay. While it does that, we're going to go to build properties and actually set it to 0.13.6, which is probably the version that you should be using. As of right now. So now if we go to Sbt, it will actually need to download 0.13.6, which is going to look pretty much the same, but not exactly the same, but it doesn't really matter. So if you're just starting with Scala, use this version until they freaking fix all of these silly bugs. I can't believe this. Okay, so it almost finished downloading. It actually took some time. What I want to show you is, before it finished, that you see that it downloads a bunch of things, and every artifact that it downloads is a Java archive. Like, look over here, .jar, 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 because we're in the Java world. So in the for the Java virtual machine, every program ends up in a jar. And in case it's not obvious yet, there's a way to tell Sbt to generate a jar for your project, so for your program, which is not something that we're going to do today, by the way. All right, so it actually took a while, and in fact there was a problem. If you encounter the problem like that, error wrapping input stream in a GZ input stream, what you need to do is you need to go into the into your home folder, and over there will be a folder called .spt, and you need to paste in that. What it will do is in the current folder, it will find a folder called target, and it will do that recursively, and it will basically remove everything. So basically there are some stale files that cause these problems. Okay, so let's say run again, and it will compile, and we have world over here. So what I was explaining is that if you have tilde run, right, that it will wait for source changes, and once you press enter, it will interrupt that. So this is what should have happened was 104, but there's a bug which pisses me off. In any case, this is not what you want to have. So what you want to have is, if you have tilde run, and then if you go into Sublime, and let's say we have a change. We have a, say, I don't know, monkey. As I see, the file is not changed. Once I save the file, in fact, you know what? Let me not save the file. Let me press enter here and exit that. Let me start a regular terminal. And let's put it over here, and let me put Sublime over there, and let me do that, and also close all other tabs. Okay, so we have just the Scala program, and it's not saved. So let's go into our folder here, run Sbt inside of it. Okay, so if we have tilde run, right, so it says waiting for source changes. So as soon as I press Control S here, as soon as this file is changed, Sbt will understand that there's a change, and it will recompile it and rerun it. So see, compiles and runs, right? And also hold up. Okay, so also it will do that with every command. So we have tilde compile, it will obviously just compile, right? So let's say we have a semicolon over here, change, it compiles. Right, let's remove that. This is actually an arrow. Change, it compiles, there is an error, and so on. All right. Okay, so this video is already getting way too long. So the last few things that I'm going to show you is, first, you can do all of these things from outside of the interactive mode. So if you're just in the folder, let me make some method again. So you can just say sbt compile run, or it will do both anyway. So you can just say sbt run. Right? The same thing as we did with Sbt console. So it just ran and it exited Sbt. Usually this is much slower. So usually what you want to do is you want to go into Sbt and then stay in Sbt for the whole day, right? Okay, so the next thing is that usually if you have a big project, a proper project, you should have your Scala files not just randomly sitting in. Hold up, let me do it like that. Not just randomly sitting in that folder. What you want to have is you want to have a folder source main Scala, and you can also have Java. right? And let's just open containing folder for that. I'll just cut it out and put it into source main Scala. And Spt knows that Scala files are over there. So the first thing was just for convenience, just to show you how it works. But usually this is what you have: source main Scala, and in there you have your file. And let's go there again, Spt, and yeah, run. Yeah, so it knows that it's over there, compiles it, it's running, it's all good. Okay, so what else? Oh yeah, one really cool thing. You can have a configuration file for Spt, right? So in the main Spt stuff folder, you can have a file. It doesn't matter how you call it, as long as it's the extension is .spt, right? So usually people call it build, so build.spt. So inside of build.spt, what you have is, like, usually those tools like, you know, Maven, Ent, and so on, those build tools, or, you know, Node and PM and all of this stuff, their configuration is either in XML or in JSON. Configuration for Spt is actually done in Scala. It's a domain-specific language inside of Scala, so it doesn't always look like Scala, but it's Scala, so it's kind of cool. It compiles. You can write a test for it. I'm talking too fast. So whatever you write in here, you have to have an empty line after each command. So we're gonna set a few things. We're gonna say the version is 0.0.1, and let me save that actually. And in Sublime, I can say, my Sublime already knows that .spt is a Scala file, so it already highlights the syntax was with a Scala syntax highlighter. All right. So we're also gonna nail down the Scala version. Right. We're going to say that it's 2.12.4, and again, empty line, very important. Okay. Okay. So the next cool thing is, let me actually copy paste it so that I don't make an error. It's this one. So what this thing is doing is that actually let me exit Spt here again and start it in a terminal here again for you. There we go. Put it over here. So this is for this incremental compilation. This tilde thing, it's called incremental compilation. Okay. So if we're in here and we say run, for example, the first thing that it will do, hold up, what is it doing? Oh, it wasn't compiling, it was 2.12.4. All right. What was it compiling it with? In any case, so now it's 2.12.4. Right, so now if I change this monkey to hello, before just compiling and running, what it will do is it will clear all of this output, right? So let's see. See? So it started from the top. And this is very, very useful if you track mistakes. So you have a mistake here, you don't have to scroll up. You know, this is exactly where this new compilation cycle started. So it's a kind of cool thing to have there. Okay, so let me fix the arrow like that, and go to the build file, and oh yeah, but because we switched to the older version of Spt, if you go into console, oh, it already has colors. Okay, I thought it wouldn't have colors. Right, okay, then I believe we're done actually. Oh no, the last thing is that if you have multiple files, multiple programs, because you know the goal for this was to allow you to start playing with Scala already. So whereas in Java you would need a separate file for every program, in Scala, what you can do is just copy paste that. Have it over here, have program.2, so this is going to be the first one, and this is going to be the second one, so you can have them all in one file. I'm not saying you should, I'm just saying that it's possible. So then if you just say run, it will understand, hey, there are actually two applications, which one do you want to run, the first one or the second one? Let's run the second one. Okay, and also you can say run main, and you can specify exactly which one you want to run. So you can say proper program, and it will run exactly this one. And again, you can also do the same thing from outside. So if you go out, spt run main proper program, let's run this second one. It should go in, compile if necessary. Oh no, it didn't like run main. Okay, maybe hold on. I think we need to do that like that. Yeah, there we go. So now it worked. It says here second. Okay, All right, there we go. So this was not like a super proper introduction to SBT, but this will get you started. And during this whole playlist, I'm sure that we will touch on one or two more topics concerning SBT. We will go into the build file. We will add a few lines. That will do some more things. I'm sure that we will download a testing framework at some point, and SBT will manage all of that for us, which is kind of cool. And again, one last thing, it is also possible to do all of that in Windows. Just a little bit different. You just download SBT, you download Java, you go through the installers, all is good. Okay. All right. I hope you enjoyed this video. In the next one, we're actually going to start talking about Scala itself. And yeah, I hope you liked it. Let me know what I can do better the next time, except for the fact that I should make those videos shorter. I'm really trying, but it just doesn't work. All right, that's it. Happy New Year. Cheers.